Last week, we started our plan formula. This time, we think about indefinite integral of our plan. If we think about the indefinite integral with the arc length formula, then we will define the arc length function. Let's say y equals function f of x when the domain is from A to B and the given curve is a smooth curve. Arc length function is defined as an indefinite integral. We denote it as S of x. It goes from specific lower bound, but upper bound is a random number rather than specific number. So we denote it as x, and the formula is the same as before. 1 plus f prime of t squared dt. Since this is non-specific number, this character and this character must be different character. The circumstance is like this point is fixed, A and f of A, but we just gradually increase the value of x, and we just trace the graph this way, and then we just think about how the arc length changes. So Q is non-specific number, which is whose coordinate is denoted as x and f of x, when y, the function y is f of x. We know the fundamental theorem of calculus. So if we differentiate that, then by the fundamental theorem of calculus, it becomes 1 plus f prime of x squared. So we can rewrite that as 1 plus dy over dx squared. In other words, we can rewrite that as ds is square root of 1 plus dy over dx squared dx. I will appreciate if you activate your camera. Otherwise, I may go faster than you desired, because I don't know what you're doing, and I will not wait, even if you're not ready. So this is the arc length function. So subsequent problems are about finding the arc length function when the initial point is given. The problem is find the arc length function for the curve y equals 2 times x to the 3 over 2 with starting point p0 4, 16. Since we will follow the formula, what we have to calculate first will be y prime. So y prime is 2 times 3 over 2 x to the 3 over 2 minus 1. So these two will cancel each other. And so that is 3 times x to the 1 over 2. So we use the R-Planck formula. The starting point of the x value is 4. So lower bound is 4, but upper bound is a non-specific number. So we decided to present it with x. And the formula goes as 1 plus y prime squared dt. So inside of that, that will be t-related function. So 4 to x square root of 1 plus, instead of x, we will write t, 3 t to the 1 over 2 power squared dt. Of course, these will cancel each other because in this case, we have to multiply the exponent. So this becomes 4 to x square root of 1 plus 90 dt. So I think probably it was better to write this down more precisely. So the exponent will be distributed. So that is 3 squared times t to the 1 over 2 squared. So the first number is 9, and then these will cancel each other. And so 9t. And then we want to use the substitution method. What we will do will be you will put u equals 1 plus 9t. And then du becomes 9 dt. So dt can be written as 1 over 9 du, right? And we are changing the variable. And so lower bound and upper bound will change according to the t value. So if t equals 4, then u equals 1 plus 9 times 4, which is 36 plus 1 will be 37. This is 7. If t equals x, then u equals 1 plus 9x. Let's do a substitution based on what we did. Then the lower bound became 37 and upper bound became 1 plus 9x and square root of 1 plus 9t was u, and dt can be written as 1 over 9 du. Let's write 1 over 9 in front of the integration. So integration 37 to 1 plus 9x. Let's raise it as a power. Then that is 1 u to the 1 half power u. So that is 1 over 2. And the denominator will be 1 over 2 plus 1, because we have to add 1 to the power. lower bound is 37 and upper bound is 1 plus 9x. And then 1 over 2 plus 1 is 3 over 2. That is in the denominator. So we will multiply by the reciprocal and just eliminate the denominator. And then u to the power is 3 over 2. So it is from 37 to 1 plus 9x. So there is no such cancellation. So 2 over 27. The 1 plus 9x to the 3 over 2 minus 37 to the 3 over 2. And that is the arc length formula. Any question? No question? Can I move on? First page. Are you talking about this or this? Okay. This page. Let me know if you're ready. Next example is find the arc length function for the curve y equals sine inverse of x plus square root of 1 minus x squared with starting point 0, 1. The general process will be the same. So we think about the derivative of y, and then we will use the arc length formula. Y is given as sine inverse of x plus 1 minus x squared. To apply the derivative formula, we will write the power form of square root. So y prime is 1 over square root of 1 minus x squared. That is the derivative of sine inverse. And then the second one, we will use the chain rule. So we do as it is usual. So 1/2, 1 minus x squared, 1 over 2 minus 1. But we have to differentiate inside of the parentheses. So that makes we have 2 minus 2x, right? So this one becomes negative 1 over 2. So that can be written as 1 over square root of 1 minus x squared. And then we notice that everything is multiplied, and this 2 and this 2 will cancel each other. And the minus is multiplied. So we will just write minus in front of that. And this is negative power, so it will induce the fraction. And this part will be located in the denominator and -1/2 power, so we have to put square root. So square root of 1 minus x squared, and the numerator is x. So this 1 minus x over square root of 1 minus x squared. So the Auckland formula goes like 0 to x because the starting point is 0, 1. We are using x variable, and so we think about the x coordinate at the starting point. So 0 to x, square root of 1 plus y prime squared dt. We already calculated the y prime, so we'll just insert the square root of 1 plus this one squared, so 1 minus t over 1 minus t squared root of 1 plus t squared dt. So we square the numerator and the denominator. Okay, so it goes like integration 0 to x square root of 1 plus 1 minus 2t plus t squared over 1 minus t squared dt. So of course, you know how to do 1 minus t squared. You can do FOIL or you can use formula. Right? So let's do the common denominator. The first one is 1, so that is 1 over 1. So it becomes like 1 minus t squared over 1 minus t squared plus 1 minus t squared in the denominator, and numerator is 1 minus 2t plus t squared. So the denominators are the same, so we can just think about the operation on the numerator. These two cancel each other, and then it becomes 0 to x, and 1 plus 1 is 2 minus 2t over 1 minus t squared dt. So that is from 0 to x square root of, what is the numerator? We take out t, 2. So 2 times 1 minus t over, here is the formula, a squared minus b squared factors into a minus b times a plus b. We will use that. So 1 minus t squared can be perceived as 1 squared minus t squared, and then it can split into 1 plus t times 1 minus t. So that is 1 minus t times 1 plus t in the denominator. Any ambiguity in the calculation? I can clarify. Okay, so these two are the same So we cancel those out. And then we have integration 0 to x square root of 2 over 1 plus t dt. So this part can be written as square root of t over square root of 1 plus t. And this number can be written in front of the integration. So we can write it down as square root of 2, 0 to x, 1 over square root of 1 plus t dt. What we are doing is just the substitution method, but there's nothing in front of t, so we will just record u equals 1 plus t, and then du is dt, and so it is fairly simple, and so we will not talk about change of variable, and then this can be written as this entire thing can be written as 1 plus t to the negative 1 over 2 power, right? So when we integrate, it becomes 1 plus t to the negative 1 over 2 power plus 1, and divide by the same number in the exponent, and 0 to x because we just didn't use the variable. If you calculate the denominator, then that is 1 over 2, and that appears in the denominator. And so we can multiply with the reciprocal, so square root of 2 times 2 over 1, which is 2. And then the numerator becomes 1 plus t to the 1 over 2 power 0 to x. As our last step, all we have to do is just we will write this one as 2 square root of 2, and then we will do substitution. Then that will be 2 square root of 2 square root of 1 plus x minus 1. That is the end of this section, and we are moving on to the parametric curve defined by parametric equations. This section is kind of a review of the trigonometry course. Where did I get -1? If we plug in 0 here, then 1 to the 1/2 power is 1. But this is in the lower bound, so we have to subtract that number. Any other question? Template 1 is about the curve defined by parametric equations. In trigonometry, you learned about the parametric curve. Parametric curve is defined on the real number line, closed interval in the real number line. Let's say that is A to B, and the interval is denoted as I. So I means interval. And I said that is the real number line in the real number line. The domain of the curve is the closed interval in the real number line. And the curve has an image in the function value in the plane, xy plane. So this is a closed curve, but there is a starting point, and there is an ending point. So this is so-called parametric curve. T is parametric curve. So I introduced the notion of initial point. And the terminal point. Initial point starts at A, the image of A. So that is denoted as f of A and g of A. So, and the terminal point, that is the image at B. So f of B and g of B. So what you can notice from here is the image is not just a one real value, that is the coordinate form of the value. So the x and y are defined as two functions, f of t and g of t. That is the equation for the parametric curve. And the point in the domain in the parametric curve is called parameter. Let's say that is t, then that is parameter. So that is this point. So, and the functions which defines the x coordinate of the image and y coordinate of the image are called parametric equations. Interesting aspect of the parametric curve is if we have a number line, then we can decide which one is bigger and which one is smaller. So we can think about the direction, concept of direction from the smaller value to the larger value, and we can denote that with arrow. And we can just trace the curve, and then it will still have a direction. As t increases, that arrow can go somewhere. Arrow doesn't have to go only one direction. It can oscillate, just go to the right and to the left. But anyway, we know that there is a direction. So when we consider the parametric curve has trace, so that is image and direction and speed. The speed means how fast this arrow moves. The other aspect of parametric curve is we can visualize the image set of the parametric curve. However, that is not the graph of function, and so this shape may be a random shape. It can go back and forth and go. It can go anywhere. So parametric curves image set is not the graph of a function. So that is the notion of parametric curve. Let's consider the example. The next example is about sketch and identify the curve defined by the parametric equations. X coordinate is defined as t squared minus 2t, and the y coordinate is defined as t plus 1. The method we will use will be eliminating parameter method. So here the parameter is t. So we want to eliminate parameter. At the same time, we want to combine x and y as a known equation, which we know the shape of the graph. So we look at x and y, and then what I will do will be I will choose the simpler example and a simpler one, and then we will solve for t, and then after we solve for t, we will do substitution to the other variable to combine x and y. Let's do that. If we compare x and y, then x has degree 2 and y has degree 1. So y is simple. So we will use y equals t plus 1. Then when we solve for t, we have y t equals y minus 1. And then we will plug this one into the first equation. So x equals t was y minus 1 squared minus 2 times t was y minus 1. Then we want to think about expansion, and then we will think about the simplifying. This one, that is y squared minus 2, y plus 1, minus, we do distribution. Minus 2 is multiplied to y, so minus 2y. And minus will make plus, and so it becomes 2. So x equals y squared minus 4y plus 3. Now we have to do factorization. What we know from the college algebra is 1 times 3 will make 3. And when we add vertically, that is 4, but this number is negative 4. And so instead of multiplying 1 and 3, we think about multiplying -1 and -3. And when we add vertically, we make -4, which is the number in front of y. And then that is, we are on the right direction. So when we factor, that is y -1 times y -3. So the reason we are doing this is when you look at the equation, what you can see is that x is solved as a y squared minus 4y plus 3. So that is a quadratic equation, but unfortunately x and y are switched. So x and y axes are switched. So what you can imagine is when you have a plane, the parabola shaped like this, right? And then we know that this one is positive. The highest value is positive, and so instead of pointing down, it is pointing up. So what you can imagine is maybe this shape is the correct shape. But when you consider this one, we can get the zeros. Zeros on the y-axis is 1 and 3 from y minus 1 equals 0 and y minus 3 equals 0. On the other hand, what you learned in college algebra is when two zeros are known in the quadratic equation, the axis of symmetry happens in the middle of two zeros. So 1 and 3, the midpoint is 2. So it becomes y equals 3. 2 comes from midpoint of 1 and 3. By doing this, we already figured out how the graph look like. But the aspect I told you is when it comes to parametric equation, parametric curve, it has also a direction. And so we have to denote that with the arrow. Let's visualize the graph of the function first. Then it is 1, 2, 3. And 1 and 3 are zeros. And the axis of symmetry is y equals 2. And so the parabola is obviously looking like this, right? And then we want to have some idea about how t values are involved. When y equals 1, t equals 0, because we already know that t equals y minus 1. So when y equals 1, t equals 0. And when y equals 3, t equals 2, because 3 minus 1 is 2. And when y equals 2, t equals 1. So we have a real number line. The t values which are involved is 0, 1, 2. When t equals 0, it becomes y equals 1. And when t equals 1, it goes like this. And when t equals 1, y value equals 2, as you can see here. So t equals 1 and t equals 0. And this point is from t equals 0. And this point is the image when t equals 2, right? And so t equals 0, t equals 1, and t equals 2, right? And so when we think about the direction, it is directed in this way. You don't have to think about whether that goes the other direction, because when t increases, in this case, y steadily increases. And so just say y value should steadily increase. And so there's no way that this curve goes back and forth or any other variation. Just it will continuously follow this parabola and then go to one direction. That is the direction of this graph. Any question? All right, tomorrow I will continue with the parametric curve. If you have any question, then you can remain and ask me question. And otherwise, this is the end of the lecture.